having calculated, having interpreted this point average versus study time graph, we're then asked, if somebody's studying 12 hours per week, how much would their point average seem to change if they studied an extra 4 hours per week? Well, let's put down our information. At t equals 12, the point average is going to be f of 12. We don't know what f of 12 is, although if we knew the function f prime, we would actually be able to solve what's called a differential equation, and you know that terminology at least, and find out what f of 12 is. But however, if we look at where the clock time is 12 hours per week, not the clock time, but the study time is 12 hours per week, the coordinates of this point will be 12 f of 12, and the slope of the graph at this point, now remember the graph is going to fall down below this slope line here eventually because of the way it's curving, but at this point f prime of 12 is 0.16, which means the slope of the line here is 0.16. That's 0.16 points on the point average per additional hour per week. Now, obviously if we add 4 hours per week, then we're going to have the point average going up by some amount that can be determined from the slope. In fact, since that's 0.16 points on the point average per hour, then in 4 hours it would seem that we would go 4 times 0.16 points, or 0.64 points. And that is indeed what happens, but let's look at how the symbols work. First of all, we note that the slope of the line is delta f over delta x, which is 0.16, and f represents the value of the function, and that's what we're trying to find because the function gives us the point average. So delta f is going to be the change in the point average corresponding to the change delta x in the hours per week studied. And I probably should have used delta t down here because we were using t before, but just note that I've switched from t to x here. So if delta f over delta x is 0.16, we can easily solve for delta f and get delta f as 0.16 times delta x. And of course, if delta x is 4 hours per week, we end up with this calculation. Delta f is f prime of 12 times delta x, 4 hours per week times 0.16 points per hour per week, or 0.64 points. And we'll note that this is again a picture of the differential. A differential approximation using the slope of the tangent line at this point, using the instantaneous rate at which the quantity is changing at this point, we extrapolate out and determine the approximate point average that will result at some later time or some later value of whatever the independent variable happens to be. So we've again seen an application of the derivative, of the differential.